we're rolling. Good, good, good. So today we are going to be learning about transformation graphs, or a bit of a recap from a lesson we did before. So the first one I want to focus on is this transformation graph here. If we've got the one in the green there, if we're moving it fx plus 2, what it means is we're going to move the graph vertically up by 2. So up by 2. So the graph would look like that. We moved it up 2 units, and very importantly, we label the axis with a 2. If now we had a minus 3, what do you think would happen if we've got a minus 3? Yes, you over there. Yes, come on, pay attention. Yep, okay. A minus 3, yes, right, yes it does. It means move it down by 3. So we have the down arrow there, we move it down by 3, and then we put the graph on the axis and we draw a minus 3 there to indicate that we've moved it down minus 3. Okay, that's one type of transformation graph. Let's have a look at this next section here. So we start off with our original fx, looking at the green one first. Fx minus 2. Now, normally we'd expect minuses to go that way towards the fire exit over there. Point to the fire exit with a camera a minute, just show them the fire exit. Good. Okay, but this time, if we've got a minus inside the bracket, it means you do the opposite thing. So it means that you go towards the door. Show towards the door. Excellent. So towards the door. So it means we go that way in the 2 direction there. So that minus compensates with the plus there. Opposite direction here. So we do our curve again, and we put a 2 there with the labelling of the axis. So let's see who the Einsteins in the class are there. Yeah, you over there. If we've got a plus 4, which way are we going to move? Towards the door or towards the fire exit? Correct. We're going to move 4 towards the fire exit that way. So there's a minus 4 there. Drawing it on, and that then gives us a minus 4. So those are our first 2. So 2 down, 3 to go. Okay, now this one here. If we've got f with a minus x inside the bracket, what it means is we sort of flip or reflect it on this fx axis here. So f with a minus x inside the bracket means that the graph would look like that. So perfectly symmetrical inside the bracket there. Okay, now this is where it gets painful, because if we've got a minus sign outside the bracket, it means, unfortunately, that we've got to go upside down. So, upside down, turn it, oh, I'm getting seasick here, upside down, and this is what your minus fx looks like. Please, can you turn it back up again? I'm about to... Right, okay, good, right, we're back to normal again, right. So, on to the next one. Yeah, so on to the next one. We might have had to join these 2 videos together to make one big video. So we've got a 2 inside the bracket this time. So we've got a 2 inside the bracket. So f2x. What it means is the pattern repeats twice within one cycle. So there, twice within one cycle. So it's 2 drops. A bit like frequency graphs. So twice within a cycle. Now this one here, if we've got a half inside the bracket, it means it takes twice as long to complete, or it only completes half within the cycle. So we've got to stretch it out like that. So a half x with the red pen will actually look like that. So that's pulling and pushing in a horizontal direction. Now, finally, we've got to pull and push in a vertical direction, and this is what the last board's all about there. So let me draw in the fx curve there. We can do a curve that goes like that, up and down like that. So we're going to do a half fx, means that we actually squeeze it down. So that means it will go down, squeeze like so. So it's only half as high. And then finally, the big 2 outside the fx means we've got to stretch it that way like that. So it's going to go all the way up and then all the way down like that. So you've got 2fx. to describing these transformation graphs. So hopefully this little video will show you what to do, how to answer that question successfully, but be careful, one of the questions has got a combination of these two transformations in, so look carefully for that. So there we go, transformation of graphs.